All right, guys, now we're going to graph exponential functions, graphing exponentials. Exponential functions look like this. They have some some number here raised to the x power. Your x is the exponent. That's why it's called the exponential function. See what I did there? All right, let's look at one here. It says graph f of x equals 2 to the x. Now, one thing I know, points that are on the graph work in the equation. So, when you start learning how to graph stuff, you start making XY tables like this. You need to plug like 0 in for x. Think about what anything is to the 0 power. It's 1. So 0, 1 is going to work. Let's plug in 1. 2 to the first power is 2. Plug in 2. 2 squared is 4. So there's some more points. 1, 2, 2 to the fourth. Let's put a negative in there. If we put a negative, it flips it, remember? So it makes it 1/2, negative 1, 1/2. So what's going to happen here, long story short, the x-axis is going to be called an asymptote. Your graph will never, you can't, no matter what you plug in for x up here, you can't get a negative number for y. It's impossible. So it's going to get closer and closer to the x, but we'll never touch it. It's going to go up really quickly. It's called exponential growth. It's growing really fast up there in your graph. So like if you plug in 3, it should be at 8. I did a pretty good job there. 4 is all the way up to 16, so it's way up there. All right, let's look at what happens with the fraction. Okay, I'm going to do the same type thing here. Put my little XY table, plug in 0 again. 0 is 1 every time. Okay, that point's going to be a standard. Let's plug in 1. 1/2 to the first power. I'm just plugging him into this x right here. Is 1/2. 1 to 1/2. If I plug in 2, we 1/2 squared, which is 1/4. So it's getting closer and closer to the x-axis that way. Let's try a negative number. If I plug in negative 1, it flips it, which makes it 2. Negative 1 is 2. If I were to plug in negative 2, in here for that x, you'd flip it and square it, which would be 4. So you see what's happening? Now it's going down like this. The same kind of curve is going down instead of up. That's actually called exponential decay because it's going down from left to right. Still has an asymptote. All that stuff is still there. Here's the properties. This is a great slide. If you want to take a picture or something with your phone, this is the slide to do it. Okay, this is what the function looks like right here. It's called continuous because there's no breaks or holes in the graph. It's 1-to-1. We talked about that before. Passes the horizontal line test. The domain is all reals. It's going left and right forever. The range is from 0 to infinity because it never goes below the x-axis. It's increasing if a is bigger than 1. It's decreasing if a is a fraction that's less than 1. Okay, this is the decreasing one. This is the increasing one. Growth versus decay. The x-axis is the horizontal asymptote, and the y-intercept is 0, 1. Like we just discovered. So that's all the stuff we just did on one slide. Pretty good slide. Okay, now we're going to shift it around a little bit. The first one, it says graph these 3. Let's see if I can graph all 3 on this one graph and see what happens. It should be interesting. First of all, on that first one, I know that the x-axis is the asymptote. It's not going to touch it. Usually, I'd put a point right here at the 1, but this time, if you look at the exponent, it says x minus 2. You know what that means? It's been shifted right 2. So I'm going to take that point and shift it right 2. I'm trying to. Right there. Okay, now what I want you to do, it's not going to be exponential growth. It's going to grow really fast. I want you to plug in the next point to the right. So let's plug in the 3 up there. If I plug in 3 in for that x, the exponent becomes 1. 2 to the first power is 2. So if I go to 3, it's 2. And so my curve is doing this time. It's exponential growth, but it's been shifted over to the right. That should make sense because of what you know from what you know in the past. Okay, let me clear out this one. Let's do the next one. Change colors. Keep it beautiful. Okay, this one right here says 2 to the x minus 4. The minus 4 is on the outside, which shifts the graph down 4, which basically means it's shifting your asymptote down 4. Still going to put a point 1 above the asymptote right there because there's no shift left or right. And again, I want you to plug in number 1 to the right. So plug in 1 again. Let's plug in 1 to my exponent right there. Plugging in 1, which will give me 2 to the first power minus 4. 2 to the first power is 2. 2 minus 4 is negative 2. So I plugged in 1. And I got negative 2, which is right there. So I'm just going to graph that real quick, just like that. No big deal. One more here on the slide. It says graph this one. It's kind of the backwards order. I don't know what just happened right there. Kind of backwards order. I'm going to rearrange it and write it this way. 0.5, which is really 1/2, by the way. X, it's negative, plus 5. Now, the plus 5 on the end is going to shift your asymptote up here. We have a negative in the front. Negative in the front reflects it across the x. This time my graph's going to be down here instead of up here because of that negative in the front. We've talked about that one before. All right, because it's 1/2, it's going to be decay instead of growth. All that kind of stuff. There's a lot of stuff going on here. So instead of going 1 above the asymptote, I'm going to go 1 below the asymptote because it's been reflected. All right, now when you have a fraction like this, the 0.5, instead of going 1 to the right, I want you to go 1 to the left of the point. Okay, so I'm going to plug in -1 this time, because what a negative exponent is going to do is going to flip that 0.5. Remember, 0.5 is a half. So if you flip a half, it becomes 2. So that original one is really 5 minus 2, which is 3. So what happens, I just plugged in -1, and I got 3 right there. So I already know my curve is going to look like this right here as it goes. All right, hopefully that's making some sense to you. I'm trying to keep it as short as possible and as simple as possible to help you see what's going on. All right, compound interest, going to work with some money problems today. And compound interest is an awesome thing. It's one of the best things ever invented by man, because your money grows with you doing absolutely nothing. It's an awesome concept, and you can really do well using it if you take advantage of it. Suppose $100,000 is invested at 6.5% interest, compounded quarterly. Okay, find the amount of money in the account after 4 years. So there's our formula. All right, the A stands for the final amount, so that's what I do not know. That's what it's asking me. The P stands for principal, which is how much I started with. I'm starting with $100,000. 1 is just 1. R is the rate, which is 6.5%, but you have to change it to a decimal, so I'm going 0.065. N means how many times per year it's been compounded. It said compounded quarterly. Quarterly is 4 times a year. My exponent is N times T, which again is 4 times T. T is time. It said after 4 years. So if my exponent is 4 times 4, I'm going to erase the 4 times 4. My exponent is really 16 right there. Now, I'm going to punch that in the calculator to get the answer. And when I do that, and you do that, you should probably do this with me. You need to be very careful, because a couple things. One, you need to change that exponent to 16. Number two, there's a fraction inside your parentheses. That fraction needs its own parentheses. So I'm going to pause the video real quick. You won't know I do it. And then I'm going to punch it in and come back with what the answer is. You should do the same thing. All right, when I punch it in, I'm getting this amount, $129,422.25. Now, that's $29,400 worth of gain from $100,000. Pretty darn good. And 4 years, $29,000 for I'm doing nothing except letting somebody hold your money. Part B, let's go backwards now. When will the money reach $400,000? So the difference on this part is you're looking for the time. So I'm gonna put the 400,000 over here. That's the final amount. The initial amount is still 100,000. Everything is still the same except for one thing, and that is I don't know. I know it's 4t because it's n times t, but I don't know what t is. So this one, I'm just going to solve that equation. All right, so what I'm going to do is I'm going to move, first thing I'm going to divide both sides by the 100,000. I don't know why I put an equal sign right there. I'm going to divide both sides by 100,000. That's 4. I'm going to go ahead and work out my parentheses at the same time, which is I'm just adding what's in my parentheses. And I'm getting this in my parentheses, 1.01625, and that's to the 4t power. Now, this is going to take you back a little bit. Not long, but doing logs, all right? When you can't find the same base, you got to do log both sides. So I'm going to do log 4. You could also do ln. The exponent goes in the front over here, log 1.01625. Now to get my final answer, I'm going to divide log 4 divided by 4 log 1.01625. And let me see what I get here. Okay, when I do that, I get 21.5 years. You might want to punch it in. Actually, I did this. I divided log 4 divided by that log first. Then I divided that by 4 because there's a 4 in the front also. So that's how it went right there. All right, let's do the same thing with e's now real quick. You should have seen e in Algebra 2 and your previous math life here and there. So e is just a rational number, kind of like pi, except it never repeats, never stops. 2.71828, 18284. It keeps on going and going and going. If you look on your calculator, 2 above the on button, there's a button that says ln. If you look right above ln, it says there's a little button that says e. Oh my gosh, that says e to the x power, and that's what we're going to do. So I'm take your calculator. We're going to do some calculator practice. Hit your e button, get cubed, and that first one, e cubed, you should get 20.0855. We're going to go 4 decimal places. The second one says e to the negative 0.23. Same thing. Hit your calculator, e to the negative 0.23. And you should get 0.794. This is something you just got to do on your own. We'll do it in class tomorrow, obviously, but we'll just practice using your calculator. E to the 0 power, anything to 0 power is 1, so that's just 1. And now we're going to graph these. All right, so the first one just says e to the x power, much like before, because E is really, remember, 2.71828, and it keeps on going, but it's 2.7, which means it's bigger than 1. So it's just like we did earlier. There's your asymptote. If we raise it to the 0 power, still 1, that point still works. If we go 1 point to the right and put a 1 in there, we get e to the first power, which is 2.71828, about right there. Okay, so I can draw my exponential growth just like that. No big deal. Now the second one, e to the negative x power, makes it look like this. So it makes it be 1 over e, or I probably should do it this way, 1 over e to the x. But now it's a fraction. Okay, so because it's a fraction, obviously it's going to be decay. So still, it's the 0 power is going to be there. And remember, when it's a fraction like we did earlier, instead of going 1 to the right, I'm going to go 1 to the left. So I'm going to put negative 1 in there. If I put negative 1 in for the x, it actually gives me e, because it flips it. You know, I'm putting it right there, really. So it flips that and makes it just e, which is, again, 2.7. So negative 1 is e. Goes just like this. That's a cool looking picture. And the last one on here I have on the slide says e to the x plus 3, which is going to be the same as this graph, except it's been shifted over 3 to the left, okay, because it's a plus 3. So my first point has been shifted 1, 2, 3 to the left. The second point right here has been shifted 1, 2, 3 to the left, right there. So it's going to do this. Okay, the whole thing's been shifted left 3. All right, last slide. One of the main uses of E is interest. Okay, so it says suppose that 7,500 is invested at 7% interest, compounded continuously. I wrote that word huge, bold, italicized it, all that stuff. How much will it be worth in 10 years? All right, so the formula for continuous compounding is this. We call it the PERT formula because it spells PERT. It looks like this. A equals P is principal, how much we started with, 7,500. E is E to the RT power. Now R is the rate, which is 0.07. T is time, which is 10. So I'm going to put times 10. So basically I have this right here. I have 7,500 e to the 0.7 power. And all I'm going to do is take my calculator and punch that straight in. All right, when I punch it in, be careful. Make sure remember your E button is right above your on button, 2 buttons up. I get $15,103.15. You might want to practice punching that in while you got the answer up there. Make sure you're good at punching it in the right way. And guys, that's all there is to it. Quite a bit of stuff, but you got this. We'll take care of this tomorrow like we always do. Can't wait to see you then. Bye.